All right, so let's get started doing some example exponential problems. The first, all we're going to do is plug a value into our function here. So let's give that a shot. So this is going to be 3 raised to the power of -2. And we like to write these with positive exponents. So I can rewrite this as 1 over 3 raised to the power of 2, which becomes just 1 over 9. Now this one would be 3 raised to the power of 4. And of course you can check that, but that'll be 81. This one here is a bit trickier. So this is 3 raised to the power of 2 over 5. Now you can see why we were doing the review a moment ago. So the denominator, the 5, actually means the 5th root. And so now inside we have 3 squared, or you could have written it as the 5th root of 3, and then put the square out here. So let's move on to some more complicated problems. In this case, we were just plugging a value into our function. Now we actually want to solve for x, or solve for x. The technique I'll show you right now, it's the simplest technique possible, but it only works for a limited number of problems. And later when we talk about some of the log properties, we'll learn how to solve these at that time, or more complicated problems than these at that time. So, but if we were to start to factor these numbers here, so for example, we have 32 factors into 4 and 8, which factors into 2's and 2's, lots of 2's. So in fact, we could rewrite the 32 as 2 raised to the power of 5 raised to the power of x plus 2. And 16 would be the same idea, but of course it would be 2 to the 4th power. So I'll just do that, 2 to the 4th power raised to the power of 1 minus 2x. Now again, using our properties of exponents, you can see we'll distribute that, and we'll distribute that. So I'm going to have 2 raised to the power of 5x plus 10. And over here I'll have 2 raised to the power of 4 minus 8x. Now pausing for a moment, notice that our bases are exactly the same. And when the bases are the same, then all we have to do is say the exponents have to be the same. So now I can redo this problem much simpler. Now this becomes just 5x plus 10 equals 4 minus 8x. Right away, we've got rid of all the exponent stuff. So now it's a simple problem. Let's see. We can subtract 4, and let's subtract 5x. Subtract 5x, so we're combining like terms. So of course, this one goes away, that goes away, and I'm left with 10 minus 4 is 6. Over here, I'm left with negative 13x. So now just divide by the negative 13. Divide by the negative 13. And that becomes a 1. So our answer is x equals negative 6 over 13. And of course, you can indeed plug that into here and to here, and you can check that it really works. All right, so let's move over here and try this one here. So this is our e. And again, e is 2.718, but right now it's going to be easier just to leave it as e. So like over here, we got the bases, we made the bases the same. And I think we can do the same here as well. So on the left side, it's going to just stay e raised to the power of x minus 1. Remember, we have that property of, if we had a negative exponent, we could put it in the denominator. Well, the same applies. I can take it here and move it up. So that becomes e to the negative 4, which is raised to the x plus 1. So now I can distribute that. And e to the, in fact, let me write this slightly different on the left side. E raised to the power of x minus 1 And now over here, I will have e raised to the power of negative 4x minus 4. So again, now our bases are the same. That means the exponents have to be the same. So x minus 1 is equal to negative 4x minus 4. And combining like terms, let's add 4x to both sides. And let's add a 1 there and add a 1 there. So now we end up with, we have 5x's here. And it looks like we're going to have negative 3 here. So one more step. Divide by the 5. Divide by the 5. And we have that x is equal to negative 3/5. So there we go. So let me erase this and we'll do a couple more examples. All right, let's do 2 more examples here. So in the past, we've been able to focus on getting common bases. And it's not so clear here. So, but let's start off with factoring the 81. So 81 factors, of course, into 9 and 9. 3's. So I can replace the 81 with 1 over 3 to the 4th. Now I can rewrite this as 3 raised to the power of negative 4 using that property of exponents. And here I have x to the negative 4. So in this case, you can see we have that the exponents are the same. So then the bases must be the same. So then x must be equal to 3. All right, and our last one. So let's start over here. We can rewrite this as 5 to the negative 1 raised to the power of x plus 2. And then we could distribute that so that we have 5 raised to the power of negative x minus 2. And I did that because I noticed over here we have a 5 as well. I thought maybe the 5 could be our common base. So now coming back over here, this is a little messier, but we have that other property of exponents we talked about a little bit ago. So we have 5 raised to the power of negative x divided by 3. So we've just rewritten it as an exponential. So let me bring that down here. 5 raised to the power of negative x divided by 3. So again, 3 goes there. And the negative x just stays right there on top. So here we have common base. That means the exponents must be the same. So I have negative x divided by 3 is equal to negative x minus 2. You could just bring the x over, but I like to get rid of the fractions. So I'm going to multiply everything here by 3. I'm going to multiply every term by 3. So of course what happens here is the 3's cancel, we get just a negative x. Here I end up with negative 3x, and here I end up with negative 6. So again, combining like terms, I'm going to add the 3x to both sides. And I end up with 2x equal to negative 6. And now let's divide by the 2x. Excuse me, divide by the 2, and divide by the 2, and our final answer down here ends up being x is equal to negative 3. So there we go. Well, I hope that helps out. Good luck with the homework.